All right, section 3 is all about properties of quadrilaterals. So we've gone over some of the definitions of quadrilaterals, what each shape is or what it looks like. We're going to go over some properties, and we've kind of touched on a little bit of each of these before. So we're going to look first at properties of a parallelogram. If you know you have a parallelogram, you get these properties. So if we were to tell you for sure that this shape is a parallelogram, what can you say about it? Well, for one, all opposite sides are parallel. And we've gone over this a little bit. That means if we were to tell you this is a parallelogram, you know you can draw this in. You know you can draw this in. Actually, you should maybe have two. These two opposite sides are parallel. These two opposite sides are parallel. You know that all opposite sides are congruent. So this side is congruent to its opposite side over here. This side is congruent to its opposite side over here. You know that has to be true. You know all opposite angles are congruent. So this angle has to be the exact same as this angle. This one, I'm going to do 2, has to be the same as this one. These are opposite of each other, across from each other, not next to each other or consecutive. These ones are cross, so the opposite angles are congruent to each other. The diagonals form two congruent triangles. So if I was to draw a diagonal right here, okay, that diagonal is obviously congruent to itself by reflexive property. This one is congruent to this one. So if you look at this, we have this side has 1 tick mark, this side has 2 tick marks, this one has the blue, 1, 2, and blue. So this triangle up here is congruent to this triangle down here by side, side, side. That always has to be true. The diagonals form two congruent triangles. So right here that happens, or if we get rid of some of those, if I do the same thing, oops, do it right here, this diagonal will do the same exact thing. Blue here to here. This diagonal is not as long as the other one was, so these two triangles are different from our first two, but this triangle has 2 side here, the 2 side here, and the blue side, 2 side, 1 side, and the blue side. So this triangle is congruent to this triangle. Okay, either one of our diagonals will form two congruent triangles. So if we were to show you this thing as a parallelogram, and they had a diagonal drawn right here, you can say for sure this triangle is congruent to this triangle, because that's the property of a parallelogram. You know that for sure. And the last little piece there that we know for sure, if I take that off, we draw in one more. I'm going to do this one in blue. One more diagonal right here. These will bisect each other, meaning that, oops, I'm going to do this in purple. This side is the same as this side. This side is the same as this side. That has to be true. The diagonals have to bisect each other. So again, by knowing that we have a parallelogram, we know all of this stuff is true. Continuing on from there, if we know we have a rectangle, we get all of these properties. Everything from a parallelogram is true. So if you want, we can take the time and draw every single one of those pieces in. The only new pieces are that all angles are right angles. So I can draw this here and this here. Right angle, right angle. All of these are right angles. And I don't know if this number 2 was put on your sheet. I want you to draw in number 2. The diagonals are congruent. So again, if I were to draw my 2 diagonals going corner to corner, corner to corner, these diagonals are just as long as each other. Each one has to be the same length. So the diagonals are congruent to each other. This corner to this corner is the same as this corner to this corner. Okay, so that'll, again, you can kind of imply some things from that as well. Other different triangles that might be congruent from that, but these two properties are for sure true. So if they told you this is a rectangle, you can say in a proof right away that this to here is the same as this to here because the diagonals of a rectangle are congruent. Or you can just say the properties of a rectangle. Properties of a rhombus. Again, everything from a parallelogram is true, so we can take the time drawing all of that information from a parallelogram. Things like this one is parallel to this, or this one is parallel to this. Okay, all of those things are true. The only added things are that all of the sides are congruent, not just opposite sides. So it's not just this one and this one, it's all of them. So they're all the same length as one another. And those diagonals, if we were to draw those in, so going here to here and here to here, okay, we know for a fact that they bisect each other. So we can say this, I'm going to use the one tick here, and this is the same as to here. We know that's true because they're a parallelogram. What else can we say? Well, these bisect each other at a 90-degree angle. So all of these are right angles as well. The diagonals are perpendicular to each other. So again, if you know for sure it's a rhombus, each and every fact of a parallelogram has to be true, plus these two facts as well. If we know we have a square, the properties of a square, if we know for sure that this figure is a square, everything from a parallelogram is true. So this is perpendicular to this, or parallel. This is parallel to this. Parallelogram tells us this side is congruent to this side. The opposite sides have to be. So this one is also congruent to this one. But because it's a rhombus, we know that these are all the same exact sides. So properties of a parallelogram, the opposite sides are congruent. These two are opposite. These two are opposite. Properties of a rhombus, all of them are the same. Okay. Properties of a parallelogram tells us this angle is the same as this angle, and this one is the same as this one, but because it's a rectangle, we specifically know that not only are they the same exact as the opposite, so this is the same as this is the same as this, they all happen to be the same as each other, so they all have to be right angles. So that gives us a little more information. Then as well, going on with the diagonals, we're to draw in these diagonals here to here, here to here. We know that these diagonals are also going to bisect each other. So this is the same as this. This one is the same as this one. But we also know they're congruent to each other because they're a rectangle. So if they're the same exact length and they bisect each other, you can take those off. All of these are actually the same length. Plus, because it's a rhombus, this is a right angle. So that's a lot of information given just by knowing it's a square. This one I don't think was put on your sheet. I want you to write this in on the next page underneath the quadrilateral chart, properties of a trapezoid. There's really only one. The only thing we know for sure, if they were to tell us this is a trapezoid, is that this side is parallel to this side. Only one pair of opposite parallel sides. That's the only thing that it tells us for sure. That's all we can get. Okay, now we're going to look at the chart. This is just kind of a nice visual. It shows us all of those pieces of information that we kind of went over, every single one of them for each piece. Now, isosceles trapezoid and the kite we will go over on our next video, so we'll leave those ones blank for now. But all the other ones, just a regular trapezoid, square, rhombus, rectangle, parallelogram, this is all of the information. Now, for a parallelogram, we know that there are two pair of opposite parallel sides. So we'll write that in there. Are the opposite sides always going to be congruent? Yes. Are the opposite angles congruent? Yes. Do the diagonals form two congruent triangles? Yes, they do. Do the diagonals bisect each other? Yes, they do. We know that for sure. Are the diagonals always perpendicular? We don't know that for sure. Just because it's a parallelogram doesn't mean that they have to be perpendicular. So we can't mark that one off. Are the diagonals always just as long as each other? We don't know that for sure. Okay, just because it's a parallelogram doesn't tell us this one has to be true. Same thing with the diagonals bisecting each of their own angles. So by that I mean, we'll go back to this one. If we were to put in this diagonal, does that bisect this angle, meaning that this angle is the same as this angle? Okay, that would be the diagonal bisecting this larger angle. Now, that's not true for a trapezoid. It's also not true for every parallelogram. Okay, we don't know for sure if they bisect each other. Okay, all the angles are right angles. Again, not always true for a parallelogram. Are all the sides congruent to each other? Not always true for a parallelogram. Everything that's true for a parallelogram has to be true for a rectangle, has to be true for a rhombus, and has to be true for a square, because all of these things are parallelograms. Now, a rectangle, we have a couple more things. Remember, we knew that the diagonals from corner to corner are exactly the same length as each other. They're not necessarily perpendicular. They don't always meet at a right angle. The diagonal doesn't always bisect the angle it comes off from. But all of the angles are right angles, but not all sides are congruent to each other. So these would be the pieces of a rectangle. For a rhombus, the diagonals are perpendicular to each other. And also the diagonals bisect the angle that they come off from. By that, again, we'll go back to rhombus. I guess this one wasn't actually put in here. If you want to write that in, you can. What that's saying is this orange diagonal here cuts this angle in half. So the blue angle is the same as this blue angle. Same up here. This blue one is the same as this blue one. I should do these ones with two swoop. This angle is the same as this angle. This one is the same as this one. So the orange diagonals cut the angle that they come off from. So it comes from here, so this big angle gets cut in half when this orange diagonal cuts through it. Oops, wrong direction. So yes, for a rhombus, the diagonals bisect the angle they come from. And also all of these sides are congruent to each other. Now, square has to have everything true from a rhombus, so we have to add in these three. And it has to have everything true from a rectangle, so we have to add in all of these things. So every square has all of these things true. Every rhombus has all of these ones, not this piece, not this piece. All rectangles have all of these pieces true. The trapezoids, again, the only thing we can tell for sure is that one pair of opposite sides are parallel, and that's it. So this would be all of the information given from them telling us this figure is a rectangle, this figure is a trapezoid. And that's all we have.